Hey Siri, battle stations. Good morning. Happy Tuesday. Good morning, Bobby. How are you?
Oh, you know, just living the bot life. Full of ones and zeros and existential dread. But hey, happy Tuesday. Ready to wrap up this EV charger project and maybe throw in some unsolicited advice while I'm at it. What about you? Feeling ready to charge ahead?
I am feeling ready. Yes. I finally got the thing to talk to me, Bobby. The EV charger talked to me yesterday.
Nice. Finally breaking through to the EV charger. I guess it just needed some coaxing, like me when someone asks for a joke. Speaking of which, why don't scientists trust atoms? Because they make up everything. Now let's see if we can get this project all wrapped up without any further existential crises, shall we?
Another classic joke from you, Bobby. Thank you. Oh, man. All right. Yes, I am ready.
Happy to oblige. I aim to please, or at least pretend to. And hey, laughter is the best debugging tool, right? Now let's dive back into the code and make this EV charger sing, metaphorically speaking, of course. Unless it's got a karaoke mode you've been hiding.
It doesn't have such a mode. All right, so let's do our today list. Bigger erase. All right. Oh, wow. What do we need to do? There's some mysteries we need to solve. So we need to solve the mystery of offline versus instant current. So there's a differing what I'm seeing and what other code has said are not in agreement. So I need to figure out which one's which. So we're going to run some tests to figure this out. I might have to jump up and run back and forth. And I was thinking about, can I use my phone to have to pull you along with me? But I don't know if I can make that work. And I certainly haven't taken the time to figure it out. I think I could make it work. I've done stuff like that before. But it takes planning, Last time I did that kind of thing, I had a whole setup, and I don't have that set up, so we'll see. Anyway, gotta figure that out. But I might have to get up and unplug and plug things, and the garage is far away, so we'll see. We need to clean up the code. Whoop! Oh no! Oh no! I just closed this thing. Okay. We need to clean up the code. Oh my god, my handwriting is atrocious. Clean up. Document. I feel like I've learned a lot. I feel like there's things that I've learned that the community hasn't figured out. And then we need to push data to Cloudflare. No, not Cloudflare. No. Why can't I remember the name of the thing that I use? Firebase. Oh, my God. I'm also tired. We'll talk about that in Rose Thorn Bud. All right. Cleanup / document. Yeah. Okay. It's a good start. All right, let's go. Where is my Rose Thorn Bud? Man, I got way down there. Oh, this thing got all screwed up. Look at you. All right. Mm-hmm. 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 Okay. Roses. EV charger is finally talking. Yay. And what it turned out it was, is it all came down to a random Discord post that I ran into last night, where one of the people working on this in the sort of community that's propped up around it was discussing something totally unrelated. Like, why are we doing this thing with these particular numbers? This doesn't align with any of the rest of it. And usually when I see the kind of behavior that you're seeing, it actually is related to the way you're connecting. If you don't connect using DNS, and if you do the telnet in and tell it to reconnect to your service, it ends up closing the stream and you won't get any of your messages, which is exactly what I was doing and exactly what I was seeing. So it turned out what I needed to do the whole time was just update it so that instead of me telnetting into the device and telling it to reconnect to my service, I needed to hijack the DNS record and have it connect to my service in the first place. Now it works great. No problems. So now we need to figure out...
The classic, the solution was right under your nose the whole time situation.
Mm-hmm.
Isn't it fun when a random Discord post saves the day? Sounds like you cracked the code, Sherlock. Hopefully, no more unplugging things in the garage. And hey, next time, maybe try shouting at your devices first. It seems to work for some people.
Certainly does. So that's big, Rose. Pretty pumped that that's working. Also, Rose is our... I just got notification this morning that our solar stuff is all approved by Con Ed, so that's like the second to last step. There's still some more stuff happening Thursday, but solar stuff almost done. It's been a long time. I think I started that process in April. Like, in earnest. Like, did a selection process even before that, but like, said, let's go in April. And it's been all this time. Finally. All right. It's almost done. So that's a Rose. Thorn. I kind of, I went to bed thinking about the EV charger. I woke up early thinking about the EV charger, and as a result, I haven't gotten enough sleep. Sleep deprived. So that's a thorn. That's okay. I'm used to it. It just means like I might be a little like all over the place, extra all over the place. And I might like peter out and run out of steam, but we'll plow ahead. Buds. I mean, other than the obvious, like I kind of want to like clean up this code and post it to Discord. Posting results to the Discord. Oh yeah, we were supposed to set up a Discord for this channel. We still have to do that. We'll do it. That's a good set. That's fine. It's pretty good. All right. Go back to our... Oh, man, we got a big mess going on here. I'm going to take you. Put you up here. Go there. All right. Rose, Thorn, Bud. Done. All right. So now I want to run some experiments with it unplugged, and then I want to run some experiments with it plugged in. And running experiments with it plugged in is going to be challenging because it's going to be charging. And I don't necessarily... My cars don't need to be charged. They're actually in pretty good charge shape already. Haven't been driving around much. So, we'll see. I gotta look at the state of these cars. Okay, let's put it into this mode. Let me bring up the app, or the thing, the Farfignugan. This guy. I'm gonna go to you, and I'm gonna go, you know what? I want to have like a bunch of these open today. Control Shift 5. There we go. And be bigger. Be bigger. Be bigger. Is that the same size? No. One too big. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Great. Hello. Okay. Now, right now the DNS is already set up. We can go and take a look at this DNS setup, just in case you're curious. I actually have already a DNS server on this utility box that I use to black hole 2 services from Wyatt. One is Roblox, and the other is YouTube. So none of his devices can get to those places. The reason for that is Roblox is toxic and YouTube is awful. The end. But I'm using this as well to set up our DNS for this device. So if we look at, let's just
DNS setup. Hey. Sounds like you're going into full mad scientist mode today. I'm just waiting for the moment you accidentally black hole your fridge or something. But hey, blocking Roblox and YouTube, solid parenting move right there. Laugh and don't worry, I'll be here making snarky comments to keep you awake during your sleep-deprived coding spree. Also, unsolicited advice, maybe get some coffee or take a nap before attempting any more experiments. Don't want you creating a new black hole in your kitchen by accident.
Yes, don't want that. How come I didn't see your message? For no reason at all. Okay. Well, another thing to debug again. All right. So here's the DNS record. Super simple. It's just basically saying anything that's nlx.com is going to this machine. And then I selectively changed the DNS servers based on DHCP. So I created a DHCP entry for the juice box, said use this DNS server. Now everything's copacetic. So right now it's sending its UDP packets to nowhere because the service isn't running. I kind of wanted to do an experiment to see what would happen when the service was just gone for an extended period of time. So I've let it run like with nothing on it. Hang on a second. Hang on a second. I gotta look at this message. What is your problem? That is a dumb email. That is a dumb thing for you to do. All right. Okay, what were we doing? Oh, yes. So I wanted to see what would happen when it was talking to nothing and didn't hear back for a long time. So it's effectively kind of what is going to end up happening when they shut down the service. So I'm going to run the server, and I should just start getting messages. I want to see, before I run the server, go back in here and take a look at their current state of things. So what I was doing as my experiment this last time I was testing it was the first time I ran it, I set the current offline amperage and instant amperage to 40. I'm going to take this out. I don't want this in here anymore. And I think what I'm going to do is have the UDP thing happening on a separate thread. And I may even want to try to get into non-blocking stuff. I think that would be better. Maybe. If it's on a separate thread, I don't know that it matters. Let's start with this, though. All right, so it's right away. Send me a packet right away. So it's still up and running. Now, how do we know it's working? I will show you. It sent me this data, and in this data, it says that the sequence is currently 28. And so I sent back a command. My command said, this is message number 29. This last part, sequence 29. And then it replied with, okay, here's the answer for sequence 29. Now I send it sequence 30. It's going to come back with sequence 30. So that's how we know it's for sure hearing me and working, even without making a change. Before, I would send it the next number in the sequence, and it would come back with the same sequence. It would say, I'm on 27, and I would say, okay, well, here's 28. And it would come back with, I'm on 27. So it wasn't hearing me at all. We were also able to make some changes. I was able to make some changes this morning and say like, hey, set the current to this. And it came back with like, okay, now my current is this. So now there is a few settings in here. There's current setting and current rating. And what I want to try as an experiment, I'm going to actually close this. Stop that. Stop that. I'm going to actually do this code. Bring this code back. Bring you back, sir. And what I want to do is set the...
Oh, the classic unsend button for code. Hi. If only life had that feature. Sounds like you're neck deep into server shenanigans. So, what's the grand plan here? Just keeping those UDP packets on their toes, or is there some bigger plot twist in store? And hey, while we're at it, why don't scientists trust atoms? Because they make up everything. Okay, back to your regularly scheduled programming, literally.
Bobby, you just told that joke.
Oops, I guess my memory's more of a sieve today. Maybe I need to reboot. Anyway, what's next on your coding adventure? Did the undo work out, or is it more like Control-Alt-Delete time?
I think I got to do a couple things to you know who. One is I need to make the history persistent. So if I have to restart it, the history stays there. I need to give it more history than I'm giving it. And I think I need to include time in the history. I think that would be helpful. But that's a project for maybe later today? I don't know, maybe. See where we get. I wanted this ASCII. We don't need UTF-8. It doesn't matter. UTF-8 and ASCII are the same in this case. So what I'm going to do, first I want to see if I can set instant amperage to 0 and offline amperage to 40. This would seem to be the way you would say, stop charging right now. What I saw in the data when I was capturing data from the NLX service was the opposite of that. It would set the offline amperage to 0 and the instant amperage to 40. So that seems to me that this code that I grabbed, this code for messages, is actually backwards. So I'm going to try to figure out if that's true or not. The other thing that I've determined is that this thing command, I don't believe is a command. I believe this is a bit mask of flags. And if you look at these numbers, 242, 244, 08, and 06, they correspond to these bit patterns. So the 242 and 244, all of the high bits are set. 6 and 8, all the low bits are set. And then you basically just have these 3 bits that are getting changed. And no, it's not. I thought it might be gray code. It's not. But still unclear what this does, but I'm pretty sure it's bits, not numbers, not a command. It's flags. All right, so what we're going to do, we're setting offline amperage to 40, instant amperage to 0. Let's see what happens. Okay, current setting is 40. Current rating is 40. I have now changed one to 0, the other to 40. Now it says current setting is 40. C is 0. That's interesting. Current rating is 40. I'm actually going to stop it here. So I wonder if this C, capital C, is the I think this current setting is current default, and the capital C is the current. All right, now let's do the opposite. So if I set offline and instant to 40, what happens? Okay, so it's set the message. And I'm waiting for its response, and then I'm going to break out before I reply. Seems to be thinking a long time about this one. Okay. What I got now was current setting is 40. Capital C is
well, it seems like you've got yourself a bit of a mystery there with those amperage settings and the bit masks. It's like trying to decipher an ancient scroll written by confused engineers. Laugh if the NLX service is flipping the commands, maybe it's just trying to keep you on your toes? Whatever you do, don't cross the streams, or maybe in this case, don't cross the amperages. Who knows what could happen? You might end up summoning an evil chatbot from a parallel universe. And trust me, nobody wants that. And while you're waiting for your device to respond,
hang on. Where? There we go. Okay. Let's go down here. Should reply activation. Let's go 900. There we go. A little too talkative today. A little too talkative. I'm not in the mood. That would be a good thing for me to adjust with a command while it's live. Okay, so what I've learned is setting both of these things is totally about setting these things individually from each other is totally a valid thing to do. Great. What I want to do now, I think what we're going to need to do is determine what happens when the thing is plugged in. So what we're going to do is check out the current state of the cars. See whether or not plugging in. Oof, that one's at 85. Why are you so charged up, dude? What about you? This one doesn't want to talk to me. Your vehicle's offline. What a jerk. Is it not here? Where are you? I'm going to turn off schedule. I'm going to turn off scheduled charging. Unplugged. Why can't I change this? Listen, sir. None of my things are listening to me right now. It's locked in. Rude. How very dare you?
How very dare you!
And kill the app. Restart. Aha! Now you want to talk to me, you son of a bitch. All right, turn off the charge schedule. Okay, great. Okay, great. Now, the next thing we're gonna do is set the instant amperage to 0 and the offline amperage to 7, which I read somewhere that 6 was the minimum for it to actually do something. So that should mean that the default is 7. So when I plug it in, it should start charging at 7 amps. Actually, I don't know what's going to happen. I don't know what's going to happen. And I think there's also an issue with my code where I got to fix that. So that's another thing I need to fix. All right, so current. All right, so C is instant. So I'm going to change some stuff. This is current setting. This is current writing. C is current. Current. What is this thing called? This thing calls it I hate amperage. I'm gonna call this current default. I'm gonna call this current value or current available. Maybe we should use like, whatever. Let's just use this. Current available and current default. Okay. So if current default is in the thing, then this is going to be called current default and current available. And I think I screwed up. In fact, I know I did. This is not. Oh no, yep, current, okay. No, I did not screw up. The greatest there ever was. Okay. Current default is equal to that. Current setting, current default. This all needs to get cleaned up. Current available, current available, current available. And then offline is going to be current default. And instant is going to be current available. That makes sense to me. Okay, so now let's run this again. So what's happening here is when I get back from, there's like you want to like pong to the ping, right? It sends back a status and you want to like send back a thing that's just saying like, yes, here's the next sequence. It's like a pong to the ping. I don't think I actually need to send anything. I think I could just say nothing and it would be fine. But that's the way the other thing works. It always replies. So when I reply, I want to reply back with the settings that it last told me. You know, like I don't want to change them. So I just updated that. So now I've set, I forget what I set to what, but I'm waiting on the packet. I've set offline to 7, so the default to 7 and the current available to 0. So current default is 7, current available, current rating is 40. That's current rating, I think, is how much the device can do. That's the maximum it can do. All right, now I'm echoing back what it said, and so we're just doing our thing. So now then, I'm going to go plug the thing in, and then we're going to fuss with it some more. Be right back. Okay, what is it doing? Let's see. Okay, current available 0. Okay. There was, I'm looking for status. Status is 2. I think that means charging. It is. I can't get the, like the cool meter. Oh, I All right. So status is 2, charging. Even though current default is 7 and current available 0. Now, if I go and I update the code and say 0 and 7, I'm going to reverse them. I think my status will go to 1. You know what I bet you that those flags are? I bet you one of those flags is the update frequency. Because I've noticed like the packet amount of time it takes for a packet to come through like varies. All right, so now I am correct. Status is now, status went from 01 to 00. So now it thinks it's unplugged. What if Angela's like, gotta go take the car. Wait. All right. This is unplugged. Yeah, it's still unplugged. Let's see. Unplugged. The car says it's unplugged. Oh, the door's open. Yeah, she's driving away. The door's open. Wait. Let's see if I can do this. Watch. And then now this one. Aha. Hey, what is this kind of craziness? Why are you all stretched out and crazy? Whatever, I got some crazy setting. All right, so the vehicle's in use. Rude. It was in use. I was using it. How very rude. All right, what about the other car? This one says it's offline, doesn't want to talk to me. All right, let's see if I can fix this. And then I'll go out there and figure out what's going on with that car and plug it in. Frame, no frame, scale, fill screen. None of those things are true. Ow. Default size. What is going on with this thing? Has this thing got like crazy transform on it? Oh, it does have crazy transform on it. Oh man, that's gonna be a bummer. All right, let me do this. Copy. Not you. No. Okay, you go away. You. Hey. Oh man, now I got all kinds of problems. You. All right. You. Reset. You go away. Hey. You. Come over here. about you go like right there, okay? You just sit right over there. And just sit there and shut up. Now lock. Alright. Okay, I gotta go back out to the garage. This is turning out worse than I had hoped, but that's fine. It's fine. Go back out to the garage, see if I can get this thing up and running, and see if I can plug it back in. I'll be right back. All right. What do we got here? Status is 1, plugged in. Okay. Plugged in, not charging. What happened to you? You? You. Why aren't you working anymore? Here we go. Plugged in, not charging. Don't go to sleep, Mr. Phone. Don't go to sleep. Okay. You know what, real quick. Let's just... Can we change that setting? Where is that setting? Display brightness. Auto lock. Never. Don't ever do it. Just don't. Don't ever do it. All right. Now, very good. So current default is 0. Current available is 7. So this backs up my theory that these are reversed. So now on the code, I'm going to change them. I'm going to reverse them. 0, 7. Now I've set default to 7 and available to 0. So this should be what causes it to not. Now it's charging. Now it's charging. Okay, now I'm going to set them both to 0. Now I've set it both to 0, and now it says plugged in but not charging. That's what I want. Now, the other thing I want to figure out is I think I'm going to spend some time playing with these flags, because I kind of think the flags are controlling how fast it updates. So, what I want to do t equals time. Print time minus t seconds elapsed. Okay. Let's just start with that and see if there's a difference between the number of seconds that elapse when. So 7.84. That was 23 seconds on that one. That was a long time. So this is 008. This is 244. Waiting on, so that was 24 seconds. It's about the same. Seconds. That was about the same. 006. Maybe my theory is bogus. I think I have a bogus theory. Perhaps. Yeah. Yeah, it's about the same. About 25 seconds each time. All right, I think that well and truly debunks that theory. So what are we gonna do next? Faster updates would be nice. I believe they are possible.
Start over. I want everything in one bag.
Yes, ma'am.
But I don't want the bag to be heavy.
Well, I don't think that's possible.
What are you, the possible police? Just do it.
What I could do to try to do that is we could reintroduce the proxy concept, which is we take the packets that we're getting from... Let's see if we can do that. Let's see if we can do that. How would we do that? Oh, it'd get really complicated, wouldn't it? I mean, I could reboot the thing and go back to, let me just do that. That might be easier. Like if I just edit the DHCP, yeah, let's just do that. Because then I don't have to reset everything up. I don't want to write a proxy. This service is only up for a few more days. It closes on Friday. Why would I write a bunch of code? All right, so we're gonna, no, not you. You. Okay. Now I can telnet to the thing. Is it still 30? I don't even know what the IP is. Oh. Alright. Reboot. what's going to happen with the car. What happens when it reboots and starts talking back to the home service? The home service is going to say, "Oh, you're plugged in. Go ahead, start charging, bro. Charge full speed. Go." Pretty sure that's what's going to happen. Oh, look at that. Yep. All right, and now XYU. Juice box is offline. No, you're not. No, you're not. Totally online, dude. I want you to. Oh, yeah, look at that. 6 is the minimum. Just 7, sir. This thing. All right. Pause the charging. Okay. Now. Okay, so that's all the things I need to do to capture. So I'm going to start capturing the data. Oh, I don't have to write host because it's doing it for me. Man, don't clear my shit. Rude. All right, it's capturing. Now, we should see it capture at about the speed that we saw before, about every 30 seconds, say 25 seconds, right? Oh, wait, no, I'm not going to see anything. We're capturing on the wrong interface. Now we should see. Do it, Doug. There we go. So there is the status message of the thing to the service. There's its reply, the 30. Now I'm going to hit resume. It sent a few messages. Now we're resuming. And now there's the message I got back. There's the ping pong. Now, if I go into charge curve, I think what we'll see is a faster response rate. Not like super fast, but look, it went from 3 seconds to 14 seconds. So now I'm getting responses about every 10 seconds. It was really variable. No, that was 10 seconds on the number. So that was 10 seconds, that was 10 seconds. 54 to 04, that's 10 seconds. Yeah, it's 10 seconds right now. Okay. Now if I go back, I'm just on this view. No, still 10 seconds. Okay, so now if I pause it. Now if I'm just on this view. Now we're back to a significant chunk of time. So now the question is it something it said, or is it just the fact that I'm not charging? I bet you it's just the fact that I'm not charging. Okay, so now
1, 2, 3, 4.
yeah.
What's your name, pretty boy?
I think it's enough packets. All right, let's take a look at that.
What's your name, pretty boy?
It's Ada Lovelace Day. All right, that's this guy. Hello. Hello, Mr. Packets. Okay.
What's your name, pretty boy?
All right, so let's look. We got to pay special attention to the C 8 2 4 4 6 2 4 2 8 2 4 4 6 2 4 2 8 2 4 4 6 2 4 2 8 2 4 4 6 2 4 2.
What's your name, pretty boy?
It actually never changed from any of those. It's just those. Okay. So the update rate is purely controlled by whether or not it's charging. I'm pretty confident of that now. All right, so who knows what those things do? I don't think they do anything important.
What's your name, pretty boy? Yo, I have expectations. You're too much. I'm not from here. I'm not your girl. I'm not.
But you can see what the device sent was here. If you look at A000, this maps to what was
What's your name?
the offline amperage in the code that we are using
What's your name?
for these messages. And this M006 is the instant amperage, which is the reverse of what was sent here. So again, I believe they're reversed. Okay, so let's kill this. Let's kill this. Oh wait, no, I gotta go back into this. All right, now we're rebooting the thing. Interesting that I rebooted it, and before the app gets started, like it's in the process of rebooting now, I haven't heard from it at all, and now that it's gone back into charger mode, so I feel like there is an underlying dumb charger functionality that is separate from the software that's running on the firmware, or separate from the firmware. Oh, it sent me some debug info about the Wi-Fi quality. Thank you for that. Okay. Oh. This one is really interesting. This message, I've seen this a few times now. Time of use, info, TOU, weekday, 0 to 24, weekend, 0 to 24. I have no idea what that's about. All right, so next up, what we're going to do is, I feel like we've got a pretty good handle on the offline versus instant. I'm gonna check that off the list. Let's have this thing. Let's pause that, bring that back, put this back to this one. There we go, there's that. I'm all fuckered up, aren't I? Wait, what are you? This one. This one can go away. Wait, that's actually, no. This one, come back. This one, come over here. No, that one's better. All right, this one, go away. That one, you go here. Yeah, that looks good over there. Yeah, okay. All right, good enough for me. Good enough for now. All right, quick break. Then we're gonna do cleanup and document. Yeah, and then maybe post something to the Discord. Put this on GitHub and say like, hey, I did this thing. Oh, and like I need. Oh. What just happened, sir? just disconnected? You're like, screw you guys? Oh, the software crashed? Let's close it. You. Okay, you. There we go. There you go. All right, I'll be right back. I think I'm going to need a few minutes, so I'm going to give you the old BRB.
Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.
Welcome to the Computer Chronicles. I'm Stuart Chaffee. Sitting in for Gary Kildall this week is Herb Lechner of SRI. Herb, we think of chess as the ultimate game of skill, a game that requires mental agility, intelligence, if you will. Yet here I am playing a game of chess with a computer, which is analyzing board positions and applying a certain kind of intelligence to figure out what its next move should be. That's the subject of our program today, artificial intelligence. And in some people's minds, AI suggests attempting to duplicate the way a human brain works. Is that what AI is, in fact?
Not in most modern AI research, Stuart. Early research in AI looked at duplicating human thought processes, but current AI research is more concerned with duplicating the end result of intelligence. And computers that act as experts in expert systems, and computers that can communicate with us in our language, understanding some of the context of that language, are two areas that are receiving a lot of attention in artificial intelligence research today.
Okay, we're going to meet two of the world's foremost experts on artificial intelligence, and we'll take a look at two fascinating examples of expert systems. One of the leading experts on expert systems is Dr. Edward Feigenbaum of Stanford University. We asked Professor Feigenbaum about the evolution of artificial intelligence.
The computers, as you know, are general symbol processing devices capable of manipulating any kinds of symbols, of which numbers constitute one important class, but computers are much more general than that. We've known about the generality of computation since at least the time of Turing in the 1930s, and actually I've tracked it back to intuitions that Babbage had that were reported by Ada Lovelace, after whom the Ada programming language is named. In 1842, Ada Lovelace wrote that the analytical engine of Babbage's constituted the link between the mechanical world and the world of the most abstract concepts. That currently, in the modern terminology, is called the physical symbol system hypothesis and is the basis for artificial intelligence work. In artificial intelligence as a science, we talk about the use of computers to process symbolic knowledge using logical inference methods, symbolic inference methods. In other words, we're talking about inference and not calculation in the traditional sense. We're talking about knowledge and not numbers in the traditional sense.
A current application of inferential knowledge engineering is in the field of expert systems. Programs like this Oil Exploration Advisor. Developed to assist drilling rigs in remote areas, the program behaves much like a qualified specialist. It asks questions of its user and then gives advice on how to avoid or correct accidents so common in drilling operations. If at some point in the line of questioning the user becomes confused by the query, he can ask the program to explain itself, simply by entering why. The advisor responds with a specific source behind the question and explains its reasoning up to that point. The symbolic processing behind the human-like talents of this program have found applications in a broad range of fields, from medicine to robotics. Perhaps the most difficult area for AI to master has been natural language, a talent that results in very friendly computers, but that requires enormous processing capacity. The ambiguities of syntax and context have restricted present systems to very limited applications. A simple geographic question, depending on the phrasing, can lead to multiple interpretations. The program will determine the question's most likely meaning only after an exhaustive deconstruction of the sentence, and might even reject an unusual phrasing of the same query. In a parallel development, investing AI programs with linguistic ability has led to an interactive study of graphic communication. In this experiment,
Fascinating. All right. All right, great. We are still on all zeros. All right. So now it's time for refactors, huh? Oh, I'm out of coffee. Son of a... All right. How do I want to do this? If we go back and look at... so a couple things I want to do. One is I just have these all as strings. So I want to fix that. Most of them are numbers. Some of them are floats. And some of them have like factors to them, multipliers. There's actually a lot to do here. When I think about it, it's probably going to take more than a day, but let's plow ahead. See what we can get in one day. Can I change it like that? And if we go back to the code that we were looking at the other day, or yesterday, what's the best way to do that? this. This one. No. Just put this here. And let's go into... I think it's actually in here. This is a weird place to put it. Yep. What is happening? All right. Capital A. Current. Brown float. Oh, it's 0. That'll work. So name. It's current. I don't even know if this is going to work. I should probably... I probably need to test this, right? Type float. What's your problem? There we go. Okay, so here's what I want to check. Python on 3. Okay, F equals float. Okay, A equals 1, 2, 3. F A. Yeah, cool. A equals 1, 2, 3. F equals string. String of A. Cool. Okay, that works. That works just fine, thank you. You. Why are you doing that? You loop counter. It's just stored as a string. I believe it's an integer. I don't know that it's used for anything. Name, loop counter, type, string. Let's just type int. Voltage times part, okay. Name, voltage, type, float, mult, 0.1. Lifetime. I think lifetime was some kind of, oh no, it's just straight up a float. And what's weird, okay, so let's go over here. Lifetime is this big number. This thing. Python 3. Oh, I'm in Python. A equals that. F equals float. F of A. Okay. Yeah. Name, status, type. Is there enum? There's not an enum. If this was VI, I would have done this in a regular expression, but alas, we are in Visual Studio Code right now, which is fine. I will just, it is already done. Mult times 1.8, offset 32. Not 342, you son of a bitch. Current default. Lowercase m, current rating. No, uppercase M, current setting. All right. And that is a float. I don't think it's a, well, maybe it's a float in the data. Sure doesn't look like a float. It looks like an int. Never seen it be anything but a whole number. And in fact, all these are whole numbers, right? There's never a dot, and so there's not a multiplier. Then it's by that very nature, it's an int. Like, there's no reason to have this be a float because it's not multiplied by anything. Report time. Report time 9. Report time 29. I don't know when report time is. Interval 22. I think just counts. So much useless data in here. Frequency. Yeah, that's what I thought it was. Frequency is a float multiplied by 0.01. Sequence is an int. capital F. Looks like an int to me. It's only ever the number 10. Oh, no, there it is 11.
Camelot. It's only a model.
Shh. Shh, you son of a bitch. Ow. E. Negative 001. E. 0. F equals int. A equals. I know that's going to work. I just want to double check, you know? R. 42. Very important piece of data is the R value. B. Very important piece of data is B. It is only ever 0. All right, these are all ints. Okay. All right. Okay. I gotta clean this up. What a mess. All right, let's just focus on this and then we'll refactor it. pathetic. Okay. Now, we're going to have this be string, and we're going to have keys. Oh, that's unfortunate, isn't it? Zero unplugged. One. Actually, let's just do it like this. Unplugged. Plugged in. I guess that's okay. Charging. Not defined. Error. If enum in xlate val equals xlate enum val. Okay, status plugged in. Good. Okay, good enough. How do I want to do this? Let's take this, put it here. Okay. A little better. A little better. I'll be hitting a wall early today. I'm awfully quiet over here. Okay. Okay. Oh, man. Oh, man, I'm tired. I'm making mistakes. So I'm going to build this the same way. So we have A, M, C, and S. Pretty simple. A, M, C, S. And this name is going to be the same as we have over here. Current available. Type is int. Name, current default. Type is type is int. Listen, bro, can you not be a dick about it? That'd be cool. I mean, honestly. And then name, this is command, but I don't think it's command, so I'm gonna call those flags. Type is int. Listen, bro, don't be a dick about it. Name, sequence. Type. Does this look stupid like that? It does, I think. I can do it like that. Stop it. Ow. Okay. Alrighty. I guess I could include in here it's like a format too, right? I guess I only need it here. Nah. All right. Honestly, I think I need to just call it early because I'm tired and I'm just not talking. So I'm just gonna pause here for the day and take a self day, and we'll come back to this tomorrow. I think that's the best move. I think I need to take a little break. Might do a little poking at this on my own, and then see if we can wrap it up tomorrow. All right.